If you have a severely inflamed knee, a cortisone injection feels like magic. Within days, the swelling subsides and the debilitating pain fades away. But fast forward 6 months, and the story almost always changes. The ache creeps back into the joint, and in many cases, it hurts worse than it did before the shot. This happens because modern medicine often operates under medical reductionism. We tend to treat the human body like a machine made of isolated, easily replaceable parts. If the knee hurts, we assume the problem is limited to the knee. A corticosteroid injection treats that local area. It acts as a highly effective, localized chemical fire extinguisher to put out the inflammation. But it does absolutely nothing to repair the physical mechanics of the joint. Treating this specific symptom of pain ignores the larger mechanical failure throughout the body that caused the fire to start in the first place. For centuries, classical anatomy has taught us to view the human skeleton as a vertical stack. We picture bones resting directly on top of one another, carrying our weight like stacked bricks in a column. The problem is, a structure of stacked bricks would instantly collapse under the dynamic twisting forces of human movement. A brick column cannot sprint, jump, or throw. Early anatomists mapped hundreds of individual muscles and bones with surgical precision, but they often cut away and discarded a continuous layer of connective tissue, assuming it was useless biological packing material. That discarded layer is called the fascia. It is a dense, three-dimensional web of connective tissue that wraps and connects every single muscle, bone, and organ in the body. To figure out why a localized cortisone shot ultimately fails, we have to throw out the machine model entirely. We need to look at human movement through the lens of this continuous fascial web. In 1955, the architect Buckminster Fuller coined the term tensegrity to describe structures, like his geodesic domes, that achieve stability not from stacked weight, but from a continuous network of distributed tension. This abstract 3D model shows what happens when we apply this concept to biology, creating biotensegrity. In the human body, bones do not actually rest on each other. They float as rigid compression struts within a continuous tensioned network of fascia and muscle. Because this network is entirely interconnected, a pulling force in one area immediately affects the rest of the structure. A persistent tightness in your right shoulder transfers mechanical strain all the way down the fascial lines to your left hip. Now apply this mechanical logic to a patient. An unresolved tightness in that hip creates an asymmetrical pull on the leg. To keep you upright, the knee is forced to bear abnormal compression, eventually creating a highly inflamed hotspot. This reveals the central flaw of the cortisone shot. The needle put out the chemical fire in the knee, but the tensegrity imbalance pulling from the hip is still there, grinding away at the joint with every step. This structural web doubles as a massive neurological network. Fascia is packed with hundreds of millions of sensory receptors, making it the most hardware-dense environment for internal body awareness. The entire tissue is packed with specific sensory nerves, like Pacini and Ruffini mechanoreceptors. These receptors constantly monitor microscopic changes in how your body stretches and distributes physical loads. This animation of a magnified collagen fiber shows the piezoelectric effect in action. When you apply mechanical pressure to the collagen fibers inside the fascia, the structural deformation literally generates a bioelectrical spark. These electrical signals travel as afferent feedback, distress signals moving from the body up to the central nervous system. The brain receives this data and actively dials down the motor output to the muscles, inducing local fatigue to protect the joint from further damage. The sharp pain and inflammation in your knee is an intelligent, functioning alarm system. It is a protective signal from your nervous system, demanding that you fix a structural imbalance. Let's look at that cortisone injection again, knowing what we now know about the sensory web. Pumping strong painkillers into the joint functionally severs the afferent communication line. It effectively blinds the brain to the distress occurring at that specific location. Without that crucial pain signal, the brain allows you to continue running on a compromised joint, absorbing the full mechanical load without any protective hesitation. Silencing the alarm bypasses the body's natural defense mechanism of central fatigue. The uneven tension continues unchecked, and the underlying damage to the bones and cartilage accelerates. A cortisone shot provides immediate temporary relief, while the structural house is still burning. True lasting healing requires us to step back and look at the entire tension network. We have to address the global structure, rather than hunting for a localized fix. Therapies designed specifically for this web, like structural integration pioneered by Dr. Ida Rolf, focus on physically redistributing tension across the body's fascial meridians. These methods rely on neuroplasticity. By changing the mechanical tension, they retrain the central nervous system and the muscles to adopt new, balanced motor patterns over time. Localized shots offer temporary relief, but they fail over the long term because they target the symptom, leaving the underlying systemic failure completely untouched. In a bio-tensegrity system, everything is connected. The site of your pain is rarely the actual source